Today we're going to look at fitting a trigonometrical model to a given function if we have the graph drawn. We're going to review what we saw last time first. So we've got the three coefficients. We're going to be doing this in degrees. On the AISL course, we always model trigonometric functions in degrees. We have the three constants a, b, and d. Now x is going to be in degrees, so for us to find the model here on this one, you might want to start by finding the principal axis first. The principal axis can be easy in the model like this one because it will be the point where the graph cuts the y-axis here at this point. This gives us the principal axis of y is equal to -1. If the graph doesn't cut there at that point, when you're doing real life modeling, it gets a little trickier. So one way you can find this is that d is given by the formula max plus minimum divided by 2. In this case, we have our maximum at 2. We have our minimum at -4. That's going to give us -2 divided by 2, which is -1. Next, we want to find our value for A. A is the amplitude. Typically, it's the distance from the principal axis to the maximum, or the distance from the principal axis to the minimum. But if you can't find the principal axis, you can find it another way using the minimum and the maximum. So the maximum minus the minimum divided by 2 will give you the amplitude. So that's going to be 2 minus -4 over 2, which is 3. The period. So to find the period, we need to find where the curve repeats itself. So to find where the curve repeats itself, if you've got the principal axis, so you need to cross the principal axis twice. When we've crossed the principal axis twice, we've got the period here. In this one, it's 180. Once we've got the period, b is given by the formula 360 over the period. So b is equal to 360 degrees divided by the period. You can't always find these 2 points if you don't have the principal axis, so often you have the maximum and minimum. So you can find the period in a few different ways. The period can be found as the distance between 2 maxima. So the distance between 2 maxima will give you the period. Here we have 225 minus 45, which is 180. If you don't have a whole period drawn, maybe you have 1 maximum and 1 minimum. So you can find the period this way. This way it's going to give you half the period. So you're going to calculate half the period. Let me do the calculation for you on this one. We've got 135 minus 45, which is equal to 90 degrees. Now that's half the period. So half period is equal to this. This implies the period is equal to 2 times 90, which is 180 degrees. Okay, so these are the formulas we're going to use. Let's put that into practice with a more of a real-life example. We have the function given here. We want to plot the data. We can do this on the calculator. I'm showing that in a different video. So in this case, we're just going to try and go straight to B, finding the model. On this, it is more tricky by hand. What we have to do is we have to make some assumptions. So we have to assume which of these is a maximum value and which is a minimum value. In a wordy question, maybe this can be inferred. Maybe the period can be inferred. In a wordy question, maybe you're talking about modeling temperatures in a city over the course of a year. So then you've got 12 months is the period. Maybe you're told in the question somewhere what the maximum and minimum heights are. And this can be very useful for us. In this question, I don't have any information like that one, so I'm going to have to assume. I'm looking for the largest value in my data set. So here is the largest y value. I'm going to assume that's the maximum. Looking for the smallest value in the data set. And here, I'm going to have to assume that this is the minimum. So this is a max, this is a minimum. So I can use these now to find the coefficients A, B, the constant D. So A, if you remember, is the maximum minus the minimum divided by 2. That's going to give me 13.4 minus 4.1 divided by 2. And it's going to give me the number 4.65. B is the period. So to find the period, I've got a minimum and a maximum, so I can find the half period. So the half period is going to be equal to 14 minus 10, which is 4. This implies the period is going to equal 8, which implies that B is equal to 360 degrees divided by 8. That's going to give me 45. So, divided by 8. Which is 45 degrees. Okay, lastly, D. D, we can have the maximum plus the minimum divided by 2, which is 13.4 plus 4.1 divided by 2. And that's going to give me 8.75. So now we have our model. Y is equal to 4.65 sine 45x. So we have to assume this is in degrees. So I'm going to remove that from there. So sine 45, x is in degrees, plus 8.75. And this is our model. We can compare this to the one that we get from regression, which we'll do next.